Hello, this is a brief description of United States patent number 8925251, which is titled Constant Force Spring Perimeter Door Seal for an Electromagnetic Shielded Door. The intent is to license the patent rights to any interested parties. You're probably familiar with the existing technology for RF shield doors, where you basically have a knife edge that scrapes between two rows of spring fingers like that. That works really well from an RF standpoint, but in the operation of the doors with this type of technology, it poses many problems. Because of the tremendous force that's required to open and close this type of door, there's usually large handles, massive thick doors, as you can see, like this, linkages, rollers, cam blocks, pivot points, bushings, basically dozens of moving parts to open the door. Actually, that's just to close the door. To open the door, you basically just need brute force to pull the door open, and that becomes quite difficult. This leads to many maintenance issues, failures of the moving parts, complaints from the users about how hard it is to open and close the door. And I've actually even heard of somebody being trapped inside of an RF shield room because one of the door members broke and made the door inoperable from the inside. The invention described in this patent is different. It utilizes what's called a constant force spring, and a constant force spring is basically a flat coiled spring that uncoils and coils. And in this case, you have a flat section of a door, a little hard to see here. You have a flat section, imagine this on a door, and we'll show you a little bit more later. And as the door closes, it unrolls the spring, still keeping metal-to-metal contact between the door member and the spring. You could also have a scalloped effect on the door member that matches the radius of the spring, which will increase the surface area. A normal commercially available door latch would be enough to close the door. You don't need all that huge leverage points. And also, this gives you constant metal-to-metal contact, which gives you an effective RF shield. Furthermore, when the door is unlatched, because of the nature of the spring, as the spring coils, it forces the door open. So there's no operator effort needed. Basically, the door just opens by itself. We'll see a little bit more coming up. Okay, what we have here is a very crude prototype of the constant force spring perimeter seal. Here you can see we have two rows of the coil springs going around the perimeter of the enclosure. In this case, it's a 1 foot copper enclosure, but the same configuration would be used if this were an RF shield room. This panel represents the inside of a door or hatch. You see it has a flat surface that comes in contact with the coil springs. So as the door closes, again, that flat surface makes contact with the springs, giving you full metal-to-metal contact all the way around. And as the door is unlatched, the springs recoil, which will pop the door back open. Coming up, we'll do some actual tests with this crude prototype. And even though this is pretty crude, you'll see how effective the RF shield is. Okay, in this first demonstration, we have a log periodic receive antenna inside the shielded enclosure, and that's sitting right on top of an RF amplifier with a transmit antenna a few inches away from the receive antenna. And what we're doing here is we're looking at the RF noise that we're picking up with the receive antenna that's inside the shielded enclosure. This is a full span that's going from 10 kilohertz up to 1.8 gigahertz. So as you see, we've got lots of broadband noise, and then I'm going to come over here and shut the door. There is a glitch in the spectrum analyzer that's not really there, that spike, so ignore that. And that's another anomaly with the spectrum analyzer. But you'll see that all of the broadband noise has been completely eliminated. Okay, once again, this is with the door open. And this is with the door closed. Again, you need to ignore those two spikes. That's what happens when you buy a used spectrum analyzer on eBay. And again, you'll see that all of the RF noise has been knocked down. We open the door again, and you'll see that it comes right back. And again, we'll close the door one more time. Okay, in this demonstration we have a signal generator / amplifier above the shielded enclosure with the transmit antenna a few inches away from the receive antenna, and we'll take a look at the noise and what the closing of the door does here. Okay, here's the noise that's being generated by that transmitter sitting on top of the box with the door open. And then we're going to close the door, and we'll see that all of that RF energy has been blocked. Once again, we'll open the door, and then we'll close it again. So in summary, we have the constant force spring perimeter door seal for an electromagnetic shielded enclosure. This is covered under U.S. patent number 8925251. This invention will reduce manufacturing costs, eliminate large handles and complicated latching mechanisms, reduce warranty claims, and give improved reliability, create a door that opens and closes very smoothly, eliminate potential failures of latching mechanisms, reduce complaints from customers about the difficulty in opening and closing doors, no more concerns about operators being trapped inside of a room. Again, this can be used for new construction as well as for retrofits. And basically you will have happy customers because this is a much easier and simpler way. If you're interested in obtaining the rights for this patent, please visit my website at www.emidoor.com. That's emidoor.com. Thank you very much.